This is lesson 1.3, evaluating exponents and roots. In this lesson, you'll be defined what it means to evaluate. You should be able to identify what a base and an exponent of a power is, write a power in an expanded form, evaluate powers of both positive and negative numbers, define or identify a radical and a radicand, and evaluate the square root of perfect squares. Oftentimes in directions you'll see the word evaluate. Evaluate is an action of finding the one numeric value that's equivalent or equal to an expression. Powers can be evaluated, or exponents can be evaluated by first expanding them and then multiplying. So an exponent is simply, or a power is simply, a base or a number that's being multiplied by itself several times. The exponent tells you how many times it's being multiplied. For example, instead of writing 3 times 3, you can write 3 to the second, or 3 to the power of 2. Instead of writing 5 times 5 times 5, you can write 5 to the fourth. The larger number is the base, and the smaller number is the exponent. Exponents are written smaller and up in the air. So the base is the number that is repeatedly multiplied. The exponent tells you how many times the base should be multiplied by itself. It's a shorthand for repeated multiplication. Altogether, it's called a power. Sometimes it's also called exponential form of a number. So when you're evaluating exponents, you need to first expand it so that you know what you're multiplying. Here's 2 to the third. So notice we are multiplying the number 2 3 times. We are not multiplying 2 times 3. To get the 2 down there is the base, and the 3 is the exponent. It means that it's being multiplied by itself 3 times. When you evaluate it, you're trying to find the one numeric value that it's equal to. To solve it, you would have had to do 2 times 2 to equal 4, and then the 4 times 2. So the way you read a power, for example, 2 to the third power, so that you read the base as the number, and then the exponent you read like as if it was a position of people standing in line, 2 to the third. The expanded form is when you show what all the numbers you're multiplying together. And then standard form is the evaluated answer, the one numeric value. So let's check your understanding of this and write problems number 1 and 2 in expanded form, and then write it in standard form to evaluate it. So 4 to the fourth in expanded form is 4 times 4 times 4 times 4. Now this is algebra class, and we said before we're no longer going to use the x to show multiplication. So let me rewrite that. Let's use the dot here. 4 times 4 times 4. Sorry, my dots aren't as easy to write. Times 4. So to evaluate it, we have to multiply two numbers together at a time. 4 times 4 is 16. Then you'd have to multiply that 16 times 4. So 4 times 6 is 24, carry my 2. 4 times 1 is 4, plus 2 more is 64. And then you'd have to multiply 64 times 4. Four times 4 is 16, carry the 1, 24 is 20, so 256. You would not answer this by 4 times 4. What'd you get for 6 to the second? There again, I showed you how I got that. 6 to the second is the same thing as 6 times 6, which equals 36. great way to help you remember your exponents is think of a basketball player. The base is your ball and the exponent is your hoop. The base is like saying how many points shot were you making, and then how many times do you put it in the basket. So 3 to the 4th is 3 times 3 times 3 times 3. Now we know there's no such thing as any point shot over 3, but you get the idea. So let me write another one and just show you what you can do if you ever forget how to solve exponents. So we had 5 to the second. Well, that 5 is your base, like the basketball. And the 2 is your basketball hoop. Tells you how many times you're going to put it in there. So this is the same thing as 5 times 5. Well, it's 5 times 5? 25. So 5 to the second is 25. To write 7 times 7 times 7 in exponential form, you would write 7 to the third. So the 7 is the base because that's the number that's being multiplied. The 3 is your exponent because it's being multiplied by itself 3 times. You try 3 to the third. If you want to push pause and then push play when you want to check your answer. 3 to the third, to solve it you would do 3 times 3 equals 9, and then take that 9 and multiply it by 3 one more time to get your 27. So you've multiplied the 3 1, 2, 3 times. How would you write 4 times 4 times 4 in exponential form, or as a power? 4 to the third. Oops, I kind of went there fast there. I was going to give you time to do 5 to the third. 5 to the third is 125, but again, that would be 5 times 5 times 5. So you'd have to first multiply the first two 5s together to get 25, and then multiply 25 times 5 to get the 125. These are on your paper, so you can work them out and then answer them. What's 7 to the second? Sorry, just a... Exponents of 2 are very common in mathematics. If your base is less than 10 or less, then you should have these memorized or be able to answer these pretty quickly. 7 to the second is the same thing as 7 times 7. What is 7 times 7? 49. How would you write this in exponential form? Did you put down 9 to the 4th? Here we have 9 to the second power. Again, this one should be pretty easy for you. 9 to the second is the same thing as 9 times 9, which is 81. 8 to the second is 64, because it's 8 times 8. Alright, take some time to evaluate this one. Check to make sure that you're doing these right. Push pause and evaluate it, and then push play when you're ready to check. Alright, 3 to the 4th. Did you expand it out? Oops. Did you get 81, I guess? Let me show you how I got that. Let's see, did you write 3 times 3 times 3 times 3, and then you multiplied 3 times 3 to get 9, multiplied the 9 times the 3 to get 27, and then 27 times the final 3 to get the 81. Exponents can be solved pretty quickly using a calculator, so I'm going to pull up some pictures of some calculators and show you the buttons that you would need to use in order to solve exponents on a calculator. So here I have pictures of 3 commonly used calculators. That you may have one of these, or your instructor might have one that you can use in the classroom. To solve exponents using any of these calculators, you will use the exponent button. The exponent button may look different on different calculators. On this first calculator, it's this caret symbol right here. There's the key for exponent. On this graphing calculator, they have the same symbol, just in a different location. On this third calculator, they have this button right here that has the x and y. It looks like an exponent. In all three of these calculators, if you were to calculate the power of, say, 3 to the 4th, you would type in 3 on your calculator, hit your exponent button, regardless if it's a caret or the x, the y button, and then type 4 and press enter or your equal sign. Calculators are great, but they don't work really well with negative numbers. And it's very important that you look at the problem with negative numbers and ask yourself if it has parentheses or not. Parentheses make a big difference with exponents. In this problem, the parentheses is around the -2. What it's trying to tell you is that you're going to take -2 to the 3rd power. It's going to be a little bit different here in a minute when we don't have parentheses. So -2 to the 3rd power is saying the same thing as -2 times -2 times -2. Now, if you remember in the previous lesson on integers, we know when we're multiplying integers together, you simply just multiply the numbers just as if there was no negative signs. 2 times 2 is 4, 4 times 2 is 8. And then you have to determine the sign of your final answer. You may use do 2 at a time, or even in odds is actually preferred here. How many negative numbers do you have? 3 of them, right? So the number 3 is an odd number. Therefore, your final answer is negative. Let's look at another problem to compare it. Here we have -2 to the 4th power. So this, if you write it out in expanded form, is -2 times -2 times -2 times -2. Let's see how the answer would be different besides the numeric value. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Now, is your answer going to be negative or positive? Well, how many negatives do you have? 4 of them, and 4 is an even number, so your answer stays positive. So if you expand out just the number part of it, you can always tell, or should be able to know, if your answer is going to be negative or positive by looking at the exponent and asking yourself, is it an even or an odd number? If the exponent is odd, and you're taking it to the power of taking a negative number to an odd power, your answer will always be negative. If you're taking a negative number to an even power, your answer will always be positive. But be careful, that's only if there's parentheses around the number with the negative sign. So let me show you the difference. Here we have a problem, and this is actually read as -2 to the 3rd. And you're probably thinking, well, didn't you just say the exact same thing a minute ago? This actually is expanded form. The only thing that's being taken to the 3rd power is the 2, not the negative sign that's in front of that 2. That's why the parentheses are important. So you would actually expand this out in this way. In this case, the 2 to the 3rd part of the problem is almost acting like as if it was a variable, and the negative in front is acting as its coefficient. Remember, if we don't see a number as a coefficient, it's that invisible 1. So if you were to expand this problem out, you're actually expanding it as -1 times 2 times 2 times 2. This is quite a bit different than what we had before, where we where we wrote negative 2 times negative 2 times negative 2. And to show you how the answer becomes different, if we multiply 1 times 2, you get 2, and then 2 times 2 is 4, 4 times 2 is 8. Then ask yourself, well, how many negative numbers do I have? Well, just one of them, and that's odd, so their answer is negative. And you're thinking, well, wait a minute, we did negative 2 to the third power earlier, and didn't we get negative 8? That's the same answer. Let's compare it to the next problem. Here we have negative 2 to the fourth power. Or this is a negative 2 to the fourth, which is the same thing as negative 1 times 2 times 2 times 2 times 2. So we did 1 times 2, you get 2. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. How many negatives do we have? Just one, which is a non-number, which makes it a negative 16. Remember before when we had negative 2 to the fourth power, our answer was a positive 16. So what's the big difference here? Besides the writing of the negative 1 off to the outside and not every number being negative, when you have a negative out in front of an exponent with no parentheses, your answer will always be negative, regardless of the power of the exponent, regardless if it's even or odd, the answer will always be negative. So watch out for those parentheses. Exponents of 0 are a little bit special and different. 3 to the 0 power is not equal to 0, even though you're thinking, well, if I multiply 3 no times, isn't that 0? It's actually 1. Can't explain it, but it is. The answer is 1. So whenever you have a number to a 0 power, it's always equal to 1. But just like before with those negative numbers that I was showing you when you don't have parentheses, in this question right here, you have that negative on the outside. That 0 is only being applied to the 2. So when you solve this, you rewrite it as negative 1 times 2 to the 0 power. Well, that 2 to the 0 power, we just said any number to the 0 power is equal to 1. So this is actually the same thing as saying negative 1 times 1. So your final answer is negative 1. Because, remember, if you ever have a negative next to an exponent that's not in parentheses, your final answer will always be negative, regardless of any exponents that you have. At this time, go ahead and complete your guided practice 1.3a. If you need to stop this video or push pause, complete it and you do your self-check and correct, and then come back to this video to finish watching the lesson of 1.3, and we'll do the practice of 1.3b afterwards. Alright, we're ready for the second half of this lesson. Before we begin, I want you to think of a number when you multiply by itself that equals 25. What number did you think of? Hopefully you said 5. 5 times 5 equals 25. The square root of a number is when you multiply it by itself, it gives you is whatever number that you can multiply by itself that gives you the original number. So what I mean by that is, in this example we have the square root of 16 is equal to 4. Because 4 can be multiplied by itself, we get the number underneath our radical sign. So here let's go over some vocabulary with square roots. 4 times 4 is 4 to the second equals 16. So the square root symbol is actually called a radical sign. looks like that. It looks kind of like a division sign, but with a check mark in front of it. The radicand is the number that's underneath the radical sign. So if you're asked to evaluate a square root of a number, you need to always ask yourself, well, what number can I multiply by itself that equals the radicand? Let's try it. The square root of 25. What number can I multiply by itself to equal 25? And we did this before. It's 5, because 5 times 5 equals 25. How about the square root of 81? Nine times 9 equals 81, so the square root of 81 is 9. Ooh, might be a tough one. 144. Well, if you think about it, let's see, 10 times 10 equals 100, so it's bigger than 10. 11 times 11 is 121. 12 times 12 equals 144. A perfect square is the product after squaring a number. 25 is an example of is a perfect square because if you take 5 to the second power, it equals 25. Is 36? Is there a number that you could take to the second power that equals 36? Yeah, 6. 6 to the second equals 36. What about 45? Is that a perfect square? No. There's no whole number that you can multiply by itself that results in 45. So 45 is not a perfect square. Here are some perfect squares that you should memorize. The square root of 1 is 1. Square root of 4 is 2. 9, 3, 16, 4. And we're just going to count up. 5, 6, 7, 8, 10. If you notice all these numbers, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, if you ever have seen a multiplication times tables or ever use a times tables, let me pull one up for you. You'll notice that all these numbers lie on the diagonal in the middle of the multiplication table. Let me show you. So here we have a multiplication table because 0 times 0 equals 0. 0 is a perfect square. 1 times 1 is 1, so 1's a perfect square. 2 times 2 is 4. So there's all those perfect squares. They're the diagonal of a multiplication times table. Sorry, I thought I pushed pause when I was trying to find something to pull up for you, so I don't know how long you've been just staring at this. 121, if you did not know this square root of 121, hopefully you did see the times table thing I was just showing. Ooh, now I'm worried about that. If I didn't, then please put it in the study log when you're done that you did not see me show you the times tables and how the perfect squares are all down the diagonal. Anyhow, square root of 121, yes, it is 11, but if those numbers start getting bigger and you're asked to find the square root, again, you can use a calculator. Let me pull up our calculator pictures again so I can show you how you would find the square root of numbers on a calculator. So it's important to remember that a square root is actually the opposite of an exponent. On a calculator, you have what's called the second or the shift button. In order to find the square root of number on a calculator, you will often have to use that second or shift button. It's generally always in the same location on a calculator, that top left-hand side of the calculator, and it may be a different color, but it's always located usually in the same spot. It's just sometimes it's called the second button, sometimes it's called the shift button. Now, a shift makes sense to me. If you notice that on a calculator, above many of the buttons, you'll see writing that's in a different color. This is like on a computer keyboard when you're trying to type like an exclamation point or a question mark. You have to push down and hold the shift key to type those characters that are above a key or up in the air. This is the same thing with the calculator. The only difference is you don't hold your shift key. What you will do is just type it once and then type the button that has the action that you want to do that's up in the writing above the key that you're trying to use. For example, you are going to use your same exponent button that you had before, or the caret button. Where was it? There's that caret button. We'll get to this one here in just a second. There's something different with that one. And this one right here as well. So what you will do then to find the square root of a number, like square root 144, 144. In some calculators you have to type in the 144 first, and other calculators you have to do the two button combination to take the square root first. So for actually for this first calculator, so some of them it looks like there's a little different. For perfect squares, and that's the only thing we're going to work here with perfect squares, notice that above the x to the 2 button right here, there is that square root sign. So in this calculator you would first push the second button, then that x to the 2 button, so that it would make the square root symbol in your calculator, and in fact in this one it will make a square root sign for you. And then type in your 144. It'll type it in for you. Just imagine that it does. And then you'd press enter. On the graphing calculator, they have actually a square root button. Yeah, it's right there. So we're not going to use the caret button. And it's the exact same process. You would type in your second button, the x to the 2, so to make the square root symbol, and then type in 144 and then press enter. There's the enter key. So enter and equal means the same thing. On this third calculator, it's a little goofy. You have to type 144 in first and then type your shift key and the x to the second key and press equals. You could also, instead of the x to the y key, you could also have used the button with the x to the 2 on it as well, because there's the square root sign right above it. So they all use the x to the 2 button, and they're just located in different spots on your calculator. How do you know which one to use? Well, take an exponent or take a square root of a number that you actually know the answer to first, just to test your calculator. That's the way you know which way your calculator is supposed to work. So like the square root of 64. I don't know why I always remember that one. 8 times 8 is 64. I ate till I got sick on the floor. 8 times 8 is 64. It's just a funny little rhyme to remember the square root of 64. So you can use that as a test to see which way your calculator works. Go ahead and do your practice for 1.3b. Try to do as many of these without your try to do as many of those problems without your calculator at first, and then use a calculator to check if you would like to. And then complete your homework for both 1.3a and 1.3b. A is your exponents and b is your roots. Good luck.